My name is Edward Elliott. I'm a lecturer in the philosophy department at the University of Leeds. In this short series of video tutorials, I want to introduce to you some of the fundamental ideas and concepts of probability theory. We will be looking at this from a primarily philosophical perspective, so I will be focused on explaining the main philosophical concepts involved rather than any of the technical details. Now, since this is the first video in the series, I'm going to start us off with an introduction to one of the fundamental concepts of the mathematical theory of probability, and in later videos we'll look at the more philosophical side of things. In particular, in this video I want to tell you about what's usually called the outcome space. Or, if you've ever seen a probability distribution before, like the one pictured here on the screen, the outcome space is that part there underneath the probability distribution itself. So before we can understand what that probability distribution is and what it's supposed to represent, we first need to understand just what the outcome space underneath it is itself supposed to represent. Now, in short, what the outcome space does is give us a way of representing the various kinds of things that have probabilities. Now, these we're going to call possible outcomes, and we're going to do this because you could think of them as the different possible outcomes of some experiment that you're conducting, where you're not sure about what's going to happen at the conclusion of that experiment. However, it's important to note that when I say experiment, you should be understanding that very broadly. An experiment in the kind of sense that I'm using it here doesn't necessarily have to be something done by a scientist, and it doesn't have to involve any special equipment or lab coats and so on. It could instead be any observation that you like. For example, it might be observing what the weather will be like tomorrow, or watching a sporting match to see who's going to win. So, a little more generally, you could think of the outcome space as representing the various different possible ways that events might turn out at some point in the future. Now, to illustrate these ideas, let me use a simple example. So imagine that you've just arrived at a very large zoo that you've never been to before. As you're entering this zoo, you find that you've lost your map of all the different exhibits. And even worse than that, you find that all the signs have gone missing. So you decide to make your way to the next exhibit, though of course you have no idea what kind of animal you're going to end up seeing next. It could be anything whatsoever. In this case, you could think of going to the next exhibit as a kind of experiment that you are conducting for yourself, and you could let the outcome space represent each of the different possible outcomes of that experiment. So, in this case, the outcome space would represent all of the various different kinds of animals that you might end up seeing next. To visualize this, you could imagine the outcome space as a box containing a large number of separate points, where each and every single one of these points represents a different kind of animal. So, for instance, this point here might represent a certain species of monkey, this point might represent a species of snake of some sort, and this one a tiger, and so on and so forth. Until, at the end of things, there's going to be a point in the box for each and every different kind of animal that you might find in the next exhibit. Note that this will also include animals that you might not even know about yet. So the box now represents all of the specific outcomes for what you might see next. That is, no matter what happens at the conclusion of this experiment, whatever animal you end up seeing next is going to correspond to exactly one point inside of this box. So that's an example of an outcome space. However, in the way that I've drawn it here, the animals have only been placed at random locations inside of the box. Although mathematically speaking this is entirely acceptable, it is also often useful to impose some kind of ordering on the outcomes. For example, suppose that there is only two things you really care about when it comes to the zoo. 1, how cuddly the animal in question is, and 2, how dangerous it is. Now, since these are the main dimensions of variation that you're interested in, it would be useful to order the points in the outcome space in a way that's going to reflect that possible variation along those two different dimensions. So, we could order the points such that over here on the left-hand side are the animals which are very safe, and on the right-hand side are those animals which are very dangerous, leaving for the middle those animals which are somewhere between being entirely safe and being very dangerous. Likewise, we could also order the points such that the higher up the animal is, the more cuddly it is. And as a result of this, on the top of the box will be those animals which are more cuddly than not, and on the bottom half will be those animals which are not cuddly. Now, if we were to order the points in this sort of way, then presumably the outcome space would look a little bit more like this. For example, the point which represents a rabbit should be somewhere over here on the upper left-hand corner, because I expect that everyone will think that rabbits are both very cuddly and not at all dangerous. Whereas the point which represents a snake is going to be somewhere down here on the bottom right-hand corner instead. Note that this is still the exact same outcome space as it was before when the points were randomly ordered. The only difference is that now we are representing the outcome space in a more ordered way, and in a way that reflects our interests. Now, the reason why it's useful to represent the outcome space in this way is that it's going to make it easier for us to talk about some of the non-specific outcomes that we're interested in. That is, while every specific point in the outcome space represents what we can call a specific outcome, sets of those points can also be used to represent what we will call non-specific outcomes. Here's an example of what I mean. Suppose we divide the outcome space up into 3 separate parts, just like this. Now the set of points on the left are going to represent the non-specific outcome that whatever animal we see next is going to be safe. The points on the right will represent the non-specific outcome that the animal will be dangerous, and those in the middle will represent the non-specific outcome that the animal will be between safe and dangerous. And notice that in the same way that you might be uncertain about what specific kind of animal you're going to see next, you will also presumably be uncertain about the general kinds of animals that you might see next, or what categories that animal is going to fall into. So you might be uncertain about whether it's going to be safe, or whether it's going to be dangerous, or whether it's going to be somewhere in between. So besides the specific outcomes of the experiment, there are also these non-specific outcomes, and you're going to be uncertain about the non-specific outcomes as well. Another example. Imagine that you were to divide the outcome space into 2 parts like this, where at the top are going to be those outcomes where the animal is cuddly, and at the bottom are going to be those where the animal is not cuddly. These again are a different kind of non-specific outcome, because they are also things about which you might be uncertain. In fact, for every single different way of grouping together points in the outcome space, you're going to have a different non-specific outcome. One final example. Imagine this time that you divide the outcome space into 6 parts, like this. Now, for instance, the set of points in the top right-hand corner is going to represent the non-specific outcome where the animal that you see next is both cuddly and dangerous. And the reason why it represents cuddly and dangerous is because it is the part of the outcome space where cuddly and dangerous overlap. And it's not just sets of points which are connected to each other which count as outcomes as well. For instance, one non-specific outcome is going to be given by the set of points that are either in the top left-hand corner or in the bottom right-hand corner. Now that set of points is going to represent the slightly more complex outcome, cuddly and not dangerous, or not cuddly and dangerous. And finally, one other outcome is going to be given by the entire set of points in the outcome space. This is sometimes called the necessary outcome, and it's called that because it's always true. You can see this by the fact that it contains all of the other outcomes. So, no matter what ends up happening, one way or another, it's going to be true that the animal you see next is going to be somewhere in that box. Now, there are 4 very important points to notice when you're talking about outcome spaces. First, some pairs of non-specific outcomes are going to be consistent with one another. In effect, what this means is that they will overlap, so it's possible for them to be both true at the same time. For instance, the 2 non-specific outcomes, cuddly and dangerous, overlap in the top right-hand corner. The second important point is that the part of the outcome space, or the set of points where 2 outcomes overlap, is what we will call their conjunction. That's the outcome where both of them are true. Third, some points of outcomes are inconsistent with one another. This, in other words, means that they cannot both be true at the same time, and in terms of the picture here, it means that they never overlap. Now, obviously, every pair of specific outcomes will always be inconsistent, so nothing can be both a monkey and a snake, but also some non-specific outcomes will be inconsistent as well. For example, Something cannot both be cuddly and not cuddly at the same time. And because of this, the set of points which represents those distinct outcomes are never going to overlap. And finally, this is perhaps the most important point, you'll also notice that some outcomes are included inside of other outcomes. So the outcome where the animal is cuddly and dangerous is going to be included inside of the outcome where it's just cuddly. What this means is that whenever the first outcome is true, the second outcome must also be true. That is, if the animal is cuddly and dangerous, then it follows logically that it must be cuddly as well. We can express this more generally by saying that if one outcome A is included inside of another outcome B, then A must entail B. Or it must follow from the fact of A that B must be true. This is why the necessary outcome, recall the set of all points in the outcome space, is always true. It includes every possible outcome, so it is entailed by every possible outcome, and if it's entailed by everything that might occur, it must therefore be necessarily true. Now that was just one example of an outcome space, but of course there are infinitely many others. Perhaps, for example, you're considering what the weather will be like tomorrow. In this case, you might want to make every single point in the outcome space correspond to a different specific way that the weather might end up being. And of course, once you've got the specific outcomes down pat, then you're going to want to order them. For example, you might want to order them such as to reflect the amount of rainfall that might occur, and so as to reflect the different temperatures. More generally, however, whenever you have anything that you are unsure about, you can usually represent the different possibilities that might end up being true using a set of points like the one that we've been using here. And you will also usually find it pretty easy to work out what are the different ways that you might want to order these points so as to reflect the things that you're interested in. So that concludes our first video. In the next video, we'll apply what we've learned about the outcome space to talk about probability functions more generally.